Metastasis right here on the lung is green from the delivered siRNA. They've also used it more recently to deliver iron oxides. And interesting, they're able to see even in lung where you wouldn't think MRI would be very effective in lung, even very small areas of tumor in lung using iron oxides. But the particle delivering the p53 complex has just completed phase 1. I don't know if they've gotten approval to go to phase 2, but they did have minimal non-limiting side effects, typical probably for particles, and they also had some anecdotal anti-tumor responses. So we'll see what happens here. Another possibility is the use of membrane-penetrating peptides, in this case chlorotoxin, done by Mi-King Zhang out of Seattle. Chlorotoxin is a viper venom, and it has a particular binding affinity for the chloride channels in glioma. And what they did in their particular case, they used iron oxide, they coated it with a polymer. They've got the homing ligand, which is chlorotoxin, which breaks through the barrier, and they also have a fluorophore. So you have the iron and the fluorophore providing two parallel signals. So in their example here, they have the optical signal where it's broken through the barrier into the glioma, and they have the untreated group here, which is basically negative in the optical field. And then here, in the MRI case, they're reporting a positive increase, but which is really, of course, for iron, a negative, and a control that's lower. So they're able to get an MR imaging and confirm it with optical, which in a mouse model of brain cancer. And I'll just point out that they're also working with the same particles, but instead of a fluorophore, it's carrying a drug. Another type of particle that you should be aware of